Recall that the domain of an exponential function of the form f of x equals b raised to the power of x includes all real numbers, and its range is the set of positive real numbers. Because the logarithmic function reverses the domain and the range of the exponential function, the domain of a logarithmic function of the form f of x equals log base b of x is the set of all positive real numbers. So, for example, f of x equals log base 2 of 16 is defined because of the value of x. 16 is greater than 0, so it is included in the domain of the logarithmic function log base 2 of x. However, log base 2 of 0 and log base 2 of negative 8 are not defined because 0 and negative 8 are not positive real numbers. In general, the domain of f of x equals log base b of g of x consists of all x for which g of x is greater than 0. Let me show you an example where we have to find the domain of the logarithmic function f of x equals log base 3 of x plus 2. The domain of this function consists of all x for which x plus 2 is greater than 0. Subtracting 2 from both sides gives us x is greater than negative 2. So the domain of this function is negative 2, infinity. We can visualize that with the graph of this function. The vertical asymptote is x equals negative 2. And all points on the graph of f have x coordinates that are greater than negative 2. Let's do one more example for the sake of practice. Find the domain of f of x equals log base 5 of x minus 6. The domain of f consists of all x for which x minus 6 is greater than 0. Adding 6 to both sides gives us x is greater than 6. So the domain of f is 6, infinity. The graph of this function looks like this. The vertical asymptote is x equals 6. And all points on the graph of f have x coordinates that are greater than 6. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.